this point, which I haven't stated what that point is, but right, that's going to be C plus delta x, this ordered pair will be, we'll write that right up here. So this is C plus delta x, and then we'll have f of C plus delta x. And of course we got to close that off. So that's going to be this point right here, the point on the curve. Now we have this distance from here to the point of where the tangent line meets the curve there, and that is delta y. I'm sure you got to be asking some questions. What this is the confusing one here. You see, when delta x is small enough, f prime of c times delta x is really approximately delta y. So as you can see here, as this distance gets smaller and smaller and smaller, right, what's happening, well, this f prime of c times delta x is really approaching the delta y here. And I don't think I left, what did I leave? Did I leave anything off here? Of course, we know this distance from here to here is our fc plus our delta x. So the whole idea is if delta x is small enough, this is going to be equivalent to our delta y. Let me just write that right here. So delta y, which is actually equal to the f of c plus delta x minus f of c, and I've kind of run off the screen over here, but right, so here's my f of c here, subtracting off from the f of c plus delta x, you get this difference right here. But when the delta x gets, right, when the delta x, as the delta x decreases, okay, this whole thing right here is approaching the delta y, and therefore we could say that this delta y, this is approximately f prime of c of delta x. All right. And of course we're going to work some problems here, but this is just kind of the picture in a nutshell. Hopefully you've made some kind of sense out of this thing. I think maybe now I'm going to work a problem first, and then we'll talk about the actual definition of differentials. How about we do that? All right.